be a live demo of AVDI and kind of a walkthrough of all the functionality that's available in it. Um, One thing I was not 100% sure on is how interactive these things normally are. So I'll just go ahead and say that at this point, if anyone has questions, feel free to go ahead and start asking them whenever. So raise a hand, post it in chat. Um, Go ahead and come off mute and speak up if you'd like. Totally open to people asking questions whenever. So feel free to go ahead and do that. And I think towards the end, we'll also have some time for Q&A if that works for folks. All right, so I'll go ahead and get into it. Basically, what I'd like to do is go through, well, what is AVDI? How does it work? Who is it for? And what's in it? So we'll get a much stronger sense of what's actually in AVDI when we look at the live demo component of this, but I wanted to set some context first. So the intent behind Azure Virtual Desktop Insights is to act as a native monitoring solution, so a first-party monitoring option for Azure Virtual Desktop. Well, what are some key items that you have to have? Visibility. When I say visibility, I mean the ability for you to look at your environment and understand pretty quickly how many users do you have, what level of activity do you have, what kind of general connectivity history do I have, things that help me understand how are things being used, who's using them, and how are things performing. Validation. And by validation, in this case, I mean, am I actually deploying a solution that's both being used by people and working the way that I expect? Can I validate that I've designed an AVD environment that's successfully meeting the needs of my user population? And finally, awareness. Primarily by awareness in this context, I mean quickly being able to tell, are there things I should be paying attention to? And also, am I allowed to set up alerts that can proactively tell me here is something that's going on in my environment that I need to do something about. So we'll talk a little bit about that. And in fact, I'll probably go a little bit under the covers here and very briefly talk about what the underpinning data is for AVDI and how you can use that for alerts. But the idea is to provide a framework where someone can very quickly understand, yes, I have a problem. No, I don't have a problem. Generate emails, notifications, things that help people very quickly know there's something that I need to pay attention to going on in my AVD environment. So, very rudimentary question here. How does it work? So, there are a few different elements here to keep track of, but I'm sure everyone's familiar with kind of the broad mechanisms by which AVD itself works. But in general, in our case, there are kind of two data generating elements. There's the Azure Virtual Desktop resources themselves. And by this, I mean the servicing components that act as the infrastructure that broker connections to session hosts for end users and basically mechanically handle the management activities and other things that go into an AVD environment's functionality. And there's the session host itself. So the session host is, the virtual machine that's serving out the experience for end users. So in our case, AVDI has those two areas as its primary source of data. So the infrastructure element of it, you may have seen when you're creating a host pool or later when you're enabling diagnostic settings, there are those checkboxes that allow you to send diagnostic information from the infrastructure itself into log analytics. This option populates things like the connection history table. It populates things like a WVD agent status health table, which is basically a history of the health of your session hosts, a whole host of things that are descriptive of the kind of servicing elements of AVD. So this is one data source, and that data flows directly into log analytics depending on your configuration. But for use with AVDI, has to go into a log analytics workspace. The other component of this is the session host. So the virtual machine that's actually servicing the sessions themselves. In this case, we have a component that sits on that session host. For the current version of the AVDI solution, we make use of the Microsoft Monitoring Agent, or as a lot of people call it, the Log Analytics Agent, to forward performance objects and event data also into a Log Analytics workspace. Now, it doesn't necessarily have to be the same workspace as you're forwarding your diagnostic information into, but in general, after user activity and brokered connections and all that, we have these two sources of data populating into log analytics, which then provides us the ability to use AVDI to analyze that information and present you with findings about what's happening in your AVD environment. So obviously users play a role in this as well. User information primarily is captured here at the kind of AVD layer, which are things like who's connecting from where, connection characteristics. As some of you may have noticed, we also have some updated tables that include things like network characteristics and round trip time. So that client data is also here in the log analytics resources for us to query for AVDI. So that's kind of a fundamental introduction to the way that AVDI itself works. Really, the only key takeaway points that I would point out here: the AVD service itself provides us with some subset of the information that we use. The session host also provides us with some subset of the information that we use. And the client details that we get come via this kind of AVD layer where we get service diagnostic details. So that being said, who exactly is AVDI for? Well, the point of this slide is kind of twofold. It's to introduce, the obvious, who is AVDI targeted at, but also to kind of hint at future roadmap developments. So this is some stuff that I can only talk to in a general sense, but we have a kind of roadmap put together for where AVDI is going that's based around appealing to these core personas. So I'll start with the desktop engineer. And effectively, this is someone who's responsible for large scale deployments or architecture of environments for end users. So the intent here is to provide the desktop engineer the ability to validate that a design that they've put together actually works the way that they expect that it should, and really critically provide someone with the ability to communicate that information to stakeholders so that they can demonstrate, yes, we set out to unroll AVD to our end user estate. Yes, we sized it correctly. Yes, it's functioning, and we have the ability to service users now in a more cost effective way, let's say, in a more optimized way for geographical locations, whatever the thing is that you're attempting to do with AVD, to be able to demonstrate that to people who care about it, that yes, everything that I designed is actually working like I expect that it should. So there are some elements that we'll take a look at in the existing offering that allow you to do that. And as you might imagine, there are some future developments that are kind of targeted at that persona that are outside of the scope of what AVDI does today, but is directionally where we're going. Next, IT service manager. So in this context, this is kind of the traditional help desk persona that you might think of, that is responsible for responding to end user events or responding to IT incidents, and require a very quick and efficient mechanism to understand what's happening in the environment so they can do root cause analysis or resolve problems for end users. So a lot of times users in this kind of persona or role might find themselves tied to SLAs, which means that they have to very quickly resolve problems. And the purpose of AVDI for that kind of a use case is to provide as much information as quickly as possible to help someone come to a conclusion like, is it an Azure service issue that's impacting this user? Is it a network problem? Is it some kind of client access issue, maybe because of versioning? Whatever it is, to provide whoever it is that's attempting to resolve the incident as much information as possible so that they're informed and able to resolve end user issues quickly, and also may not have to go down the pathway of engaging Microsoft to try and resolve their problems. So as much visibility as we can grant someone into the functionality of AVDI or AVD, and give them the ability to troubleshoot and perform those kind of IT service management tasks that you would probably expect. Next, and this is more of an aspirational goal, I'll go ahead and say right now, IT operations. So this is a role that's largely responsible for real-time performance analysis of an environment. So you can get proactive awareness and visibility into what's happening in an environment if you're having problems. So this allows, let's say, an organization that has some operations task group or kind of a job role that's defined for someone to understand and quickly address arising problems before they become widespread enough to actually impact a large set of the user population. So, this role requires real time visibility into an ABD environment. They need the ability to really quickly see evolving trends. We have some elements of that in ABDI currently, but future development here is really important for us. You will notice in the future, and I can say this, I think I can say this, the information that's presented in AVDI will start to percolate its way into other areas of the Azure Virtual Desktop portal, so that that way you'll be able to see some information that you weren't necessarily able to see previously in some new and distinct areas, including some more real-time visibility. So those are things that we're looking to in the future integrate in based off of feedback that we've gotten from, folks like yourselves and from organizations across the board. So that's kind of a future goal, but is one of the key personas we're looking to address. Finally, managed service providers and systems integrators. So the real key for an MSP or SI role is the ability to be able to query across multiple subscriptions or multiple customer organizations, to be able to service multi-tenanted deployments that a lot of MSPs or SIs might have. So the ability to query across larger segments of a population or larger deployments and across multiple host pools is really important for that kind of a use case. And additionally, the ability for us to be able to communicate some sense of an experience level agreement or a service level agreement back to stakeholders on the customer side via the data to be able to, on behalf of an MSP or an SI, demonstrate that they have created an environment that services the customer need as it should. So these are the personas that we're largely trying to address. There's a blend of current functionality, so like a lot of desktop engineering and really primarily like IT service management roles are kind of what's defined in there right now. But future development based off of feedback and vision incorporates a lot of the functionality that we have discussed for those other personas. So that being said, what's in ABDI right now? We'll take a more concrete look at this when we actually get into a live demo of it, and we'll go pretty exhaustively through each of the tabs. But the basic idea is that AVDI provides you with a few different pillars of information to help you understand your AVD environment. So I've split it out into a couple of functional areas. There's actually more to it than this, but this is kind of the foundation. Connection diagnostics. So this is everything that relates to how a user connects into an AVD environment, the quality and consistency of their ability to connect in, and characteristics of that connection. So we'll take a look at a couple of the underpinning data points for this, but it's stuff like round trip time for latency, time to be productive, which is how long does it take someone to actually broker a connection into an environment and come up with a usable session, disconnects and disconnect error messages that relate to users experiencing issues maintaining a connection to AVD, stuff like that. Next, there is session host performance characteristics. So these are things that take place on the session hosts themselves. So for a lot of cases, interesting event logs, things that are transpiring and creating errors on the session host. Really importantly, performance objects that tell us what's happening on the session host in terms of things like resource consumption and some really important things like user input delay, which we'll talk about in more detail, that help us understand are session hosts being overwhelmed by resource requirements or some other things that might prevent someone from getting a good user experience. Finally, and this is actually fairly important as well, client access details. And this includes things like user session activity, so utilization on a per user basis, which we'll take a look at, in addition to versioning for what version of the client is someone using. This can be really important, especially if a user's experiencing issues with, let's say, Teams, and they're using a version of the client that doesn't support some functionality, like that's a media redirection, for example, for Teams. This is something that you might want to use to be able to pinpoint, well, here is exactly why we think that you're experiencing that issue. Let's make sure that we can target some people for updates to their Access client, depending. So that's kind of a quick high level. Again, we'll take a look at this stuff in more detail in the live demo. But connection diagnostics and performance largely can be broken down into a couple of categories. So this is one of the key areas for us, again, just because a lot of user issues relate to disconnecting from the service or having issues maintaining a consistent connection into their AVD session host. So this includes a connection history. We have the ability to highlight failures that have taken place. So we'll take a look at what that looks like in a bit, but that helps me pinpoint errors that are taking place. We also have the ability to review the round trip time. So for those of you who are not familiar, that's effectively the latency back and forth from the server to the client and then back to the server again, which gets us an idea of kind of the full stack of the delay that someone might have based off of, let's say, geographical location or routing to and from the session host themselves. Session host details. Again, this is very important, and we'll take a look at this in the actual live demo component of this, but gives me the ability to look quickly at the status of a session host. So I've got a few different areas where I can see, well, what exactly is the session host doing right now? I can look at events. I can see, have these session hosts crossed over some known problematic threshold for user experience or the health of the session host. I can look at performance characteristics for the session hosts as well. So that's inclusive of some basic stuff like resource contention, as well as user input delay, which we'll talk about in more detail. Utilization. So really the key for utilization is being able to look at a trend of activity in a particular host pool, be able to get a sense of, well, how many users do I have active in this deployment to start off with, and how effectively am I making use of the resources? And finally, client details. Client details, again, really targeted towards allowing you to understand how people are connecting into AVD and getting a sense of, are there users out there that are not using the most modern version of a client? So that's it in terms of slide content that I've got. I'm going to go ahead and transition now into a demo of AVDI itself. Any questions while I transition over? Please feel free to ask them either in the chat. People can raise their hands, come off mute, whatever they'd like to do. So I'll pause for 2 seconds and see. All right, that's 1 and 2. So we'll go ahead and move on. So I'll go ahead and walk through a live demo now of AVDI. And again, if people have questions in the course of this, please feel free to just stop me and ask. Or we can save questions towards the end if people want to take a few minutes. I can leave probably 10 minutes or so for that. So Azure Virtual Desktop Insights lives in the Azure Virtual Desktop portal area here under monitoring and insights. So for those of you who want to play the home game, if you have an AVD deployment active right now, and if you have it configured, which we'll take a look at here in a second towards the end of this, you can go ahead and take a look at this yourself. I'm going to demonstrate one of our internal environments. So it's something that we just use to kind of get you a sense of what AVDI looks like. But this is one of our internal self-hosted environments. So this is where we actually use AVD internally as Microsoft. So under the Insights area, you'll notice that we have effectively a set of information that's broken out largely in those areas that I had mentioned before that is descriptive of your AVD environment itself. I'm going to go ahead and go through each of these tabs. I may not get to every single element of everything in here, but the major point is each of these tabs has a specific use case associated with it, and I'll speak to that as we kind of walk through them. So the overview, as you might expect, provides you an overview of your environment and some key characteristics of what this host pool is up to. So you'll notice I've got here the ability to very quickly see the number of session hosts that I've got in this host pool. I can see what their current status is right now. I can see what their capacity is in terms of their available sessions and how many sessions are active presently. Also, some characteristics about the AVD host pool itself. So, effectively, things like, is it a pooled deployment or personal? Now, each of the things that you'll find in the overview generally have some corollary that exists in each of the tabs. I'll kind of point that out when we get to it, but this is just designed to give you a more at a glance experience for things like session host characteristics and status. And as we scroll through this, some other things like here, the percent of your users that are successfully able to connect. So in general, in our case, we have a lot of successful connections. We'll take a look at some of these failure events in a second, but this allows me to see the trend of success and failure. So it actually highlights for me, and we'll take a look at this in a bit, the number of users or clients that might have particular issues connecting into my AVD environment. We'll see more detail on that under connection performance. But the key here is this very quickly helps me understand some basic stuff like, are there users that I need to pay attention to? Yes or no. Next, the connection performance characteristics. So this is how long it takes a user to be productive. I'll go ahead and call out the fact that I'm seeing some interesting numbers here. That's a little unexpected. I can go ahead. Hello?
I
Oops.
hear
Can
you.
you hear me? Okay. It said that I got disconnected there for a second. Good?
Yeah.
Okay. Let me refresh. I must have had a network hiccup of some kind. Um, right. So to pick back up from where I was, the connection performance allows me to see how long does it take a user to be productive and actually get into an active session. So there are some other items in here that are fairly interesting that we'll take a look at in more detail when we get to the relevant tab. But I also have the ability here to see, do I have any high flyers in terms of events? So you can actually see here, there are a couple of session hosts that have flagged a significant number of error or warning events. We can take a look at that in more detail as well. We also have the ability to pinpoint session hosts that have a higher user input delay. So you might see that referenced here as you input latency. User input delay is effectively how long it takes input from an end user on a client to actually result in the action that's supposed to happen in an app. So very simply, imagine clicking in an application menu. How long does it take for that click to actually result in the menu being rendered? That time that elapses is that input delay and is representative a lot of times of what the end user experience is like interacting with an app. So lower is better. The higher this is, the more you're going to notice a delay in interacting with some application on a session host. And the really important part is this is distinct from network latency in that the origin of this delay is going to be something that's happening in relation to the session host itself rather than the network connectivity that connects you to the session host. So high user input delay normally means that a session host is not able to keep up with the workload that it's being asked to keep up with. But we'll take a look at that in more detail in a bit. Finally, in the overview, there are some utilization characteristics. So you might ask yourself, what's the difference between monthly active users and daily users that are active? So monthly active users is what it sounds like. How many distinct monthly active users have you had in your environment? Daily active users is on a day-to-day basis, a subset of those monthly active users who are active. And we've got a smattering of other things that I just won't go into in too much detail. But the purpose of the overview is to get you a very high level understanding of what's happening in my environment so that quickly I can understand things like, am I having problems or are there tabs that I need to pay more attention to? So to go ahead and drill down a little bit, the connection diagnostics area is designed to allow you to get a sense of, are users able to successfully connect into this environment or not? So you can see in our case, the majority of connections are successful. So what I might want to do is focus on failure events. So by highlighting this, I've eliminated the successful connections, and I can see here that, yeah, actually fairly recently, we've had some connection errors, and I can scroll down and actually see, well, who was the user that had that problem? And importantly, I can also get a connection ID, which in this case is the specific connection that failed. I also have the ability here to look at my success rate for connecting initially. So the difference between these two is this is how successful someone is reestablishing a connection. So they already have an existing session versus someone establishing a net new connection. But the kind of, I think, most useful element of this tab is here, where I have the ability to pinpoint hosts. So in this case, session hosts, users, individual resources, or clients that have problems within this particular host pool. In this case, we've got a couple of users that appear to have relatively consistent performance issues or connectivity issues, and I can pinpoint who that user is, what are they attempting to access, and what client have they been using. So in this case, this user's used a couple of different versions of the client to connect in, but have been unable to connect or currently look like they potentially are having consistent issues. So same for client access versions. But again, the idea here is to more quickly be able to pinpoint resources that are experiencing issues or are presenting people with challenges connecting. I also have the ability here to be able to quickly search for different connection characteristics, either on a user basis or on a host basis. So let's say, for the sake of argument, that I wanted to look for a particular person. I have the ability to do that here. I can select a host that they have attempted to connect to, get some details on that connection. So we can actually get fairly granular in this, and we'll take a look at this in more detail when we actually get into the connection performance characteristics and establish some timings. But this gets you a complete breakdown of the process of the connection for this particular user. So this includes a bunch of things like timings and individual components of that connection. Like here, we've actually got some pretty interesting information about the win logon total event. Again, this gets down into the weeds a little bit, but it breaks out each component of that logon process in detail. Again, we'll see this in a graphical way in a second, but there's a lot of rich information about connectivity characteristics for end users. Finally, and this is another interesting area, I have the ability to see my most common errors. So in this case, reverse connect response time, so some network characteristics, some network connectivity characteristic problems, uh, general connection failures and disconnects, um, those kinds of problems. So this helps me get a sense of what the most common shared characteristics are for errors allowing users to connect into an environment. And again, if anyone has questions, please feel free to just come off mute, raise your hand, post in chat, send a signal flare, whatever it is that people would like to do.
There we go. We're back, people.
We're back. Hey, Amal, you have a question?
Yes, I do. I have a couple of questions, and you might be planning to cover this. But
Sure.
first question: cost implications. Of storing all this data in a log analytics workspace. How much does this consume space-wise?
Yeah, it's a good question. And in general, we're talking in the ballpark of, I think the latest numbers I've got are about 60 megs per user per day. in terms of log analytics ingestion, which is not terrible. The one thing that I have to say is that it depends a little bit on how active your environment is. And there is some variability, which we'll get to in a little bit, related to things like, let's take the user input delay object. That's going to scale depending on how many users you've got on a device and how many apps they have. So the smaller the number of apps you have, the less data you're going to get. The more apps you have, the more data you're going to get. And that performance information by far is the largest set of the data that we get for end users. So it varies a little bit, but in general about 60 megs per day. And I forget what the pricing implications are for that, but I can
Sure.
look up like what the total cost per month is, but it's not too bad. The other thing
Okay.
to think about is we use log analytics. So all of your cost at this point comes from log analytics data ingestion. And there are two elements of cost for log analytics. The first is what I mentioned, which is data that's being ingested. So basically you pay by the gigabyte for that. The second is retention. So you can retain data for 31 days in log analytics at no cost. That's just bundled in with the service. If you would like to have a richer history, like that, say I'd like to maintain my data for 3 months, 4 months, whatever, you do have to pay for that as well. So there's a small cost implication for that.
Okay. All right. Thank you. And then the other question I had was about AVD on Azure Stack HCI. Does
Yeah.
AVDI work with Azure Stack HCI as well?
Currently, it does not. Basically, there are some differences with enumeration of some of the resources in Azure Stack that just don't work exactly the same way as it does for Azure Commercial Cloud or for any of the actual kind of proper cloud offerings. So it's not supported currently. There is work underway to support it though. So that is something that's in the roadmap.
Gotcha. Okay. Thank you.
Any other questions while we're paused for a second? Going once, going twice, and sold. All right. So moving on to connection performance. This has some fairly interesting information with implications for productivity for end users. So this is broken out in a couple of different ways, but the best way of thinking about this is we are looking at in this case, rate or the amount of time it takes for new sessions to become active and interactive for end users. And we've broken this out into a couple of different timings. One of the statistical things that you'll see pretty consistently throughout this is that we'll show you a median as well as a 95th percentile offering. Hopefully that's clear enough what we're trying to communicate there. But the idea is, in general, the median is kind of like, well, the median of the connection characteristics. And 95th percentile is generally always going to be higher because it's going to represent a kind of different confidence interval than the median itself. Yeah, so not to get into that too deep, but you'll notice that throughout this. The idea here is quickly you can kind of pinpoint, do I have session hosts that appear to have high connection times? In our case, everything appears to be, for the most part, working fairly well. Some end users are actually getting longer times than others, which is why you see that higher P95 value here. But the idea here is you can break out the amount of time that it takes a user to be productive into these different phases of the connection. So just to give you a quick idea, there's user routing, which is how long it takes to actually route a user to a particular session host. Stack connected, which is how long it takes to kind of set up the guts of the connection to broker the client to the session host itself. There's the logon process, which is, well, how long it takes to log on, pretty clear, but we actually have more details on that below. I'll get into that in a second. How long it takes the actual shell, which in this case is the interactive element that someone's getting either as a remote application or like explorer.exe if they're using a full version of the desktop, and how long it takes that to become ready. So when the shell is ready, the session has become interactive for the end user and they're basically ready to go. Now, the logon process component of this actually is made up of its own elements. So it is actually more than what you just see here. So there are some things in here that can add some time, but the when logon components are basically the primary contributor to the logon time itself. So this is how long it takes for various things to happen when a user authenticates into a session and starts being logged in to whatever their session host is. So a component of this is how long does it take them to actually authenticate? So this could be like, let's say, how long it takes someone to put a password in, or it could be like, let's say they've got a smart card or something like that, how long it takes to offer that up. Uh, Group policy application. So how long does it take GPOs to be applied on a device? Shell start and FS Logic's profile time. So all of these things combined make up the total when logon time. When logon time is a component of this overall logon time, but effectively represents how long it takes the user to get from a logon prompt through those credentials being applied and all of these things transpiring to actually start their experience. In here, I can also click on a particular device to get characteristics for it. So here, things in general appear to be fairly consistent across the session hosts, which is not that unexpected. But I can drill in that way. The other thing I can do is drill in for specific problem users. So here I notice that I've got one user that actually appears to have a roughly problematic time for time to be productive. So almost 2 full minutes. So we can see exactly what happened here. And this is fairly unusual. I don't think I've ever seen stat connected take 1.5 minutes before. So take that for what you will. But the breakout here allows me to see really quickly. It's not a logon component problem, so I don't have to worry about the GPOs that I've got or provisioning for things like FS Logics because this all transpired really quickly. But this stat connect, meaning a service component of this, actually took longer than I thought. So where do I go from here? I can click on details, and this will pull up a very, very thorough overview of this connection. So this is actually inclusive of a whole boatload of details, including all the individual steps that took place to connect a user from point A to point B. So most of these have parameters or details that I can take a look at. So in here, like let's say I want to take a look at logon delay. This will pop this up. And similar for anything else that has additional details or parameters provided to it. So here this took 83 seconds. Oh, to acquire credentials. That's interesting. Anyway, you have the ability to drill in fairly granularly there, and you've also got the ability to look at errors that have applied in the case of this particular connection instance as well. So I can click through here. Again, do the same for any of the users in this list to get an idea of what's happening. In this case, we've only got a small number of users that appear to have timing issues, and they each appear to have different contributing factors to that length. Okay, so here's one where the logon process, for example, took longer than we would expect. And the major contributor here is how long it took the user to authenticate. Next, we've got the total time that it took to route a person to a session host. So in general, this should be a very short time, but we might have some outlying values in there from time to time. Finally, a very important item, the round trip time or the latency. This is network latency, which is very important to point out as being distinct from user input delay, which we'll take a look at. This gets us a sense of how the network characteristics are for users that are connecting to a particular session host. So I can see that I've got one that's kind of problematic. Well, much like some of the other ones, I can actually see that there was a time when a user had fairly bad. So at least one user in here had a fairly bad user experience because of latency, about 250 milliseconds, which gets towards being an issue. Yeah, so that click-through functionality is something that you'll find in most of the tabs as well. So that's kind of the connection characteristics. Let's do a quick time check. I think I'm good on time. And we'll move into session hosts. But while we make that transition, any questions, feel free to just raise your hand, come off mute, chat. Pause for a second. Going once, twice. All right, so the session host related information is kind of the next set of stuff that we'll take a look at. Again, we've already kind of looked at the overall status, so we'll skip through that. The real value, I think, of this tab is the ability for me to really quickly see, do I have cases where CPU utilization has been high or user input delay has been high? If so, I can click on this. What this is looking for is crossing these thresholds that I've defined here. So if user input delay, for example, has crossed the threshold of 500 milliseconds, I'd like to know about it. So here, I can see that there's been, one case of that happening. We've had one case of that happening on a different session host for CPU utilization, let's say. I can see, similarly, we haven't had a consistent case. We find one where we've had it happen a bit more, maybe. Yeah, so for some page fault history, here we've actually got a little bit more of a history of being over the threshold. So you can see over this time period, we had high page faults. So this just quickly kind of gives us a sense of, is there something I need to pay attention to with the session hosts? In this case, some light resource contention issues potentially. I'd also mentioned before the idea of looking at event logs. We have that represented here as well. So in this case, the only thing we appear to have errors with are FS logics. So let's go ahead and click on that. And I can see that we've got some issues connecting, or actually in this case, we have some space issues. So some of these have issues with the size of the VHDX files that is associated with FS logics. Now, the other interesting thing I can do from this view is pick a specific host and actually browse information about it. So for the sake of argument, let's say I would like to look at 23, looks like it's fairly interesting. I can pick that. And I can pick a particular counter. So like let's say, I want to say that this is, let's take a look at, like, let's say user input delay. Here, I have the ability to trend that over time for processes that have been running on that individual session host. So you might wonder, what are these numbers? Those are PIDs that are associated with the individual apps themselves. I can also pivot that to a per session. So let's say that I wanted to look at these sessions. These are the actual session IDs that are active or were active in the time period. And I can look at that as well. So I can see that there are some users that had a higher user input delay than others. And that might be contingent on their activity. But another interesting functionality here, the ability for me to quickly see event log issues. So if I want to sort out, okay, what's the most common error event log that I've got? I've got that represented here. I can click through and I can see exactly what the problem is. So some issues writing to something. But the host, the information that I've got available here lets me really quickly dig into a specific session host and get some high level information about what's happening on it. I can also get a broad trend for things like compute resource and memory consumption across all of the session hosts in my host pool. And again, more of an at a glance view of what's happening within the host pool itself. Cool. Next, I've got host performance characteristics. This is where we really start to focus on the idea of user input delay. So user input delay is actually a very important counter in my experience in that it tells you pretty consistently, are users experiencing problems that they're likely to notice? So that user input delay, the higher it gets, the higher the probability that you're going to very quickly run into user impacting problems, because it's very easy to notice like, hey, I clicked on this thing and it takes, a second to render whatever it is that I've tried to do, or I, type a letter on the keyboard and it takes 500 milliseconds for it to pop up somewhere. That has a tendency to be fairly noticeable. So the key here is user input delay is usually related to session host contention issues. I can quickly drill in here and say, for this particular session host, maybe I'll pick one that's got more consistent activity. I can find times where that input delay has gone a little bit higher and do some cross correlation with compute resource and memory consumption, disk performance, and really importantly, some things like disk queue length, which can also have a fairly large impact on the input delay. So if you're waiting for the disk to service requests, user input delay can actually go fairly high. And again, I have this broken out on a per process basis as well. So let's say I want to find what I have the most data for, in this case, Edge. I can actually click through and see here is a particular time, here's a particular session host where I had issues. Clear that back out so I can get more. But this allows me to more at a glance say, are there particular applications that are experiencing problems and really quickly get a sense of what the end users are getting out of their time with AVD. Next, I have the ability to search for users. So say that I want to pick someone at random here. I've got the ability to see a history for them. So how many sessions have they had? How active do they have a tendency to be? When are they active? What client access do they use? That kind of thing. I'll go through these last things a little bit more quickly just to leave some room for time and to also go into just one step under the covers. But utilization is the second to last thing we'll talk about. This gets me a sense of what the activity in my environment's like. So how many sessions have I had? So this is the concurrent sessions in this host pool. But really interestingly, what the efficiency of my environment is. So effectively, how many users per core am I getting? So I can get a historical trend for that. So obviously, the more resource hungry users are, the lower the number of users per core you're going to be able to service will be. This also supports some things like compute resource consumption over time and the availability of sessions throughout this time period, which you'll notice is kind of inversely related to the number of active sessions you have, which would make sense. So I'm not going to go through all this stuff because it also is some things you can get on the overview, but this gets you who your most active users are, what your most active session hosts are, and the connection characteristics. The last thing that I'm going to take a look at in the actual AVDI interface itself is the client view. So this gets me the ability to really quickly see what's the most common client that's in use. Well, in our case, the vast majority of people use the Windows remote desktop client. I can get a breakout of all of the activities here. So in this case, I can actually break this out on a per version basis and see what version is my most actively used. But I think my most interesting feature here is the ability to say who are users that are currently using an outdated version of the client. So I can come up with the version that is current based off of activity in the environment. So this is the latest version that we've seen versus users that have connected with a outdated version. You know, in our case, some users are actually significantly out of date. So that is the majority of the AVDI functionality. Again, we kind of talked about the broad stuff, you know, a summary view and the overview, the ability to look at connection characteristics and performance details, session host details, the ability to look up users and utilization. Again, all of that stuff is based off log analytics data, which we'll take a look at here in a second. But before I move on to kind of the nuts and bolts of a couple of the configuration options and slash data, are there any questions about anything that I've talked about thus far? Anything that people wanted to see that they did not see?
Not necessarily related, but when you mentioned client
Yeah.
data, the types of clients, is there like the plan to sort of normalize the different clients and the features that they have? So, for instance, you get the individual PC connectivity option on the client that you can download from the Windows Store, but you won't get that in the client that you get from the GitHub.
I mean, is that more of a question of the functionality of the client itself or AVDI? Because I can kind of talk to the AVDI element of it, but consistency in the client version and the clients that you get is a little outside of kind of my space.
Okay, I thought maybe you knew. No, that's just a side comment.
No, no,
So
no, no.
disregard it.
Sorry. No, that's fine. I mean, it's a good question. I don't necessarily know why there wouldn't be consistency between the two. Certainly something that I might chase down with someone somewhere. It's just unfortunately I don't know the answer to that.
No problem. But excellent presentation, by the way. Just would love to review it in the recording.
Absolutely. Thank you. Thank you. So we'll touch on a couple of things briefly, just for kind of completion's sake. So I mentioned that a lot of this stuff needs to be configured. To do that, and we're not super creative people, so it's just called the configuration workbook. This is how you actually configure AVDI. It's fairly straightforward. For a host pool, it kind of walks you through setting up the logging. It works you through setting up a log analytics workspace. It sets you up with a deployment of the log analytics agent. And really, it's as simple as just configuring performance objects. As you can see, you just kind of click a button and it'll set up a template that will get deployed to take care of that for you. So it's a fairly straightforward process. And to the question of how much data does it generate, and I think Amal, you were the one who asked that question. This is also where you see how much data have I actually generated. So in our case, and bear in mind, we have a lot more performance objects in our environment than you will in yours. There's a bunch of optional stuff turned on, so you're not going to have this volume of performance objects in practice. But you can see. In our case anyway, we've ingested over the last 24 hours about 5 gigabytes across this host pool. And this will actually break out for you, okay, well, what is it that we've ingested? So performance objects are by far the largest contributor. You can actually see that in our case, we have a couple of session hosts that are much more active than others, but this will break out for you what the key contributors are. Like I mentioned, the user input delay per process is one of the major ones, as well as breaking out a per process CPU usage. Now, this, you'll notice, is not actually in the existing deployed version of AVDI that you would be working with. This is unique to our environment, but you would get this user input delay per process. So where does that stuff all live? Which is a fair question. In this case, it lives in a log analytics workspace. And I'll go ahead and just pull up one. You'll notice here, I've got some sample queries. For those of you who are inclined to kind of get in the guts of things a little bit, you've got the ability to run queries based off the data in log analytics. Or I can show you here under log management, I've got the actual diagnostic tables represented here. So just for the sake of argument, let's say I wanted to look at some of the underlying data for some of that connection history stuff that we've taken a look at. I'll just look over the last 24 hours and show you the raw data. In this case, I've got the ability to see now the underlying details that AVDI processes into that connection view that you saw previously. With that, and I think I'm pretty good on time. I think I've left us about a 10-minute Q&A period. I'm going to put a pin in it. That pretty much represents what I wanted to get through in terms of AVDI functionality. Again, just to give us a recap, Azure Virtual Desktop Insights is designed as a native monitoring option for Azure Virtual Desktop. The intent is to get you a set of information that allows you to more quickly get visibility into what's happening in your AVD environment, get you the ability to do some validation that things are the way that you think that they should be, and awareness into either ongoing issues or net new issues that might be cropping up. Foundationally, it's based off of data and log analytics, which is where your data cost is going to come from. We provide you a mechanism to review how much data are you ingesting, which then helps you understand what your cost implications are. And yeah, that is effectively it. So thanks for your time and attention. I appreciate it. Now let's open it up to any questions that might be popping around, or if there are no questions, I can turn it over to T-Rex. So questions, anybody?
This has
So-
been great. Oh, sorry. Go ahead.
Sorry, I have one
No,
quick
just,
question.
yeah, go ahead.
Ben, sorry, so was the configuration at each host pool level? I've missed where you went to the config screen.
Correct. Yeah, the configuration takes place for each host pool. So I can walk through that again. Again, this is how it works currently. We've heard some feedback that it would be very useful to have this configuration take place when a host pool is created. So I can say that feedback has been listened to, but for now, the configuration workbook is where you go to configure it. So when you pick a specific host pool, let me see if there's one that's not configured so I can show you what that looks like. You configure it in here. If you're familiar with the diagnostic settings when you create the host pool, that's basically this stuff here where you configure what diagnostics you'd like to set up for the host pool itself. So you can do that when you create the host pool currently.
Yep, and this looks great, Ben. Thank you so much.
Perfect. And Alexander, I think you had a question.
No, I think I
Oh.
missed the beginning. And is this you load this from the Azure portal as a workbook, or how do
Yeah,
you?
exactly. Yep. It's a workbook that's in the Azure portal. It's natively presented here under the Insights area. So if I'm in Azure Virtual Desktop, there's this Insights area that takes me right to it. Or like you had mentioned, I can actually get to it under workbooks as well. Right now, it is the only workbook that you've got available in here other than check configuration, but you can get to it through via workbook. So there's a gallery entry as well.
Excellent, thanks.
Cool. Any other questions?
I had one. This
Yeah.
has been great. Thank you so much. Is there any plans to add GPU performance?
Yeah, that's a good question. We have heard feedback that GPU performance would be interesting. The short answer is yes, we do have some plans to add GPU analysis to this.
Great, great. Looking forward to that. Thank you.
Of course. All right, if there are no more questions, I guess I'll wrap it up there. So again, thank you for your time. I appreciate it. And I'll pass it over to T-Rex.
Thanks, Ben. This has been great.
Perfect. Thanks, everyone.
Excellent, excellent. Thanks, Ben. Awesome presentation. Can everyone hear me okay?
Yep.
Excellent. So I'm Tyler Rohr, T-Rex, the co-founder and CEO here at Remotely. Been in and around the end user computing space for a long time, and have seen a lot of things change over the years. And I think what I'm excited to talk to you about today is what's stayed the same. And so my presentation is kind of looking at the world through the context of no matter what your lived experience was over the last 2 years, things have definitely changed. And yet when it comes to, managing end users at scale and deployments of virtual and physical and laptop desktops, the problems remain the same. And so I thought I'd go over some of those with you today and then kind of summarize with the reason that we put Remotely out there into the market. So if you're like a lot of organizations or you work with a lot of companies around the country, you probably have seen that most companies have a ton of different users, in and across their deployments. And because of the different use cases, whether it's HR or finance or sales, we tend to provision different systems, and those different systems, because the users require different applications, begin to sprawl. That notion of the single gold image gets away from us, and we end up having a lot of one-off configurations that we need to manage a lot more like pets than livestock. You add to that, and I'm not sure if you folks have seen this, but some organizations have very unpredictable, volatile, and abusive end users. And because of that activity, specifically on physical laptops, things just break. And when they break, there's almost always a provisioning lag. The length of time it takes to get the hardware in, to test the image that we laid down, to do some DevOps or some security ramifications, then deploy it out to the end user and cross our fingers and hope that nothing goes bump in the night. But it almost always does. And we haven't really built any fault tolerance into our environments to date. And so that also creates a huge problem for, worker productivity and worker uptime. Now, you can hardly, open the internet without seeing some story about a breach or some security incident that's, befallen a big company or even a software vendor. And that's another huge, I think ramification of almost a billion people working remote these days, that security is just fundamentally more difficult when you're at a distance than when you're close by, which kind of brings up the fundamental issue a lot of us as sysadmins and IT pros work with, which is that notion of sneaker net. In the old days, to fix a PC, you actually had to go to the PC to fix it. Now, interestingly enough, this first part of my presentation is actually from a slide deck in 2009 that I did when I was on the VMware VDI team back in the early days. And I wanted to show it to you all today because the problems remain the same. Here's another one. The cost of managing a desktop, a laptop, or a PC, some estimates are 70% of the total cost of ownership is in the careful care and feeding of that asset every year. It's login, it's hard drive space, running out of hard drive space, password resets, the applications, the different elements that go on, into managing it and keeping that user productive. Now, when I started to think about, well, where are we spending all this money? It's the teams and the tasks that we all are up to every day. It's modern endpoint management. It's the physical provisioning of the device, or maybe it's the security, either the physical networking or the anti-malware or cyberware that we're putting on those different laptops or machines to keep them secure. Next are the applications that the users use to consume or create content. We have entire teams that are dedicated to rolling those out, whether it's DevOps or SecDevOps or building the internal applications we use. There's the VPN, the use of virtual networking and physical networking to help our remote users, do more things with what we're provisioning to them. Office 365 and tons more things that we can do up in the cloud with Endpoint Manager, Sentinel, Defender. I love AVDI. This is so cool to take a look at into, because my first question is there an API we could tap into? And I'll show you what that means here in a second. We also have teams that are working on, whether it's Citrix or VDI or DAS, they're also looking at, providing to that level of productivity for our end users. Last and certainly not least is our help desk. These are the folks that when something does go bump in the night with any of the different challenges or friction points that we see in front of us, they pick up the phone and try to make it right. Now, the reason we started remotely is we took a look and we said each one of these teams and tasks are on a different console. They're using a console individually, or maybe two or three, sometimes multiple consoles. Some are paid for, some are free, some are included with different subscriptions. Some are included with different, solution stacks we might be looking at. But it's really difficult if I want to get a team or a task coordinated. If I want to get multiple team members and multiple tasks accomplished, it's very difficult to take data that's stored in different localities and make it proximately functional, how to get it in one place. And the reason is that it's mostly static. If I'm pulling information, for the most part, from multiple systems and trying to compile it into a report, it exists at one point in time. It's not living like the user experience of my users. Number two is that pulling all of that data together can be just cause of errors, whether it's intentional, unintentional. The data is complex. It's often time consuming to get into a format and function where it's actually consumable by us. And the fact that it's not correlated makes it really, really difficult to make sense out of the information a lot of times. So that's why we built remotely. We wanted to build one unified console that took the different 30 or 40 different consoles that our different teams and tasks are using, provide security, support, and vision to our remote users, and put them in one place. And we decided, well, let's pick on Azure. So what we actually did was we said, okay, we've got a bunch of end user sysadmins with a ton of different, tools and consoles that they're using to provide functionality for their end users. What else are they using? And so we said there's a ton of additional consumption happening up in Azure. So whether it's Teams or Azure Virtual Desktop or the use of OneDrive, SharePoint, Defender, Office 365, these were trends that we kept seeing across, enterprises and organizations of all sizes, really. And each one of those had a console. So we said to ourselves, this is an incredible amount of information. What if we could make it actionable? Well, we decided to put remotely up in the cloud next to Azure. And today we have about 951 API calls that we're pulling from across all of the different Azure infrastructure that you may be consuming today. And I'll go over that in a couple of slides. And all of this in about 30 seconds without an agent gives us an incredible amount of information about your secure score, your exposure score, your device and update rings, your applications in Azure Active Directory, your Microsoft Endpoint Manager discovered apps, your Microsoft Defender applications. And what we start seeing is some uh-ohs. We are either not adhering to our own compliance policies, or we have rogue users who are either installing or uninstalling applications. And that gives us, a lot of information about what's happening across our entire enterprise, but it still doesn't complete the final mile of what is that actual user doing out there, on the edge. If there are a few 100 million of them on laptops, well, wouldn't it make sense to have an agent? So even though we can get a tremendous amount of information almost instantly from across your Azure tenant, really having an agent on the endpoint is incredibly powerful. I came from a company which had an agent-based monitoring solution, and I can tell you that not all agents are built the same. So we decided to build ours in native shell language. So we are built in PowerShell, and because of that, have the unique ability to interact with a front row seat with the operating system. So at a very core level, we are getting information from that end user every 3 seconds, running it to an interesting Cosmos database, which I'll talk about here in a second. And we're starting to see the context of what that remote user is up to, the time they're using their machine, the commonality with which they're using applications. Is there commonality in places where they're using different resources or networks? Who are they? Are there different roles-based action controls set up, or are they kind of out there, with full admin rights in the ether doing what they want? Of course, and I love that Ben brought this up, the basics count: CPU, memory, disk drive, the human interface devices that are plugged in or out of that machine, the different drivers that are laid down on and off of it, and then, of course, how it's actually used. If we had all of that information, we would be in a really, really unique place to start saying, aha, I can start solving some of these question marks or concerns that I have about the security or supportability of my remote users, or their applicability for a modern solution. And so that's what we did. We put that all up in one console up in the cloud. Keep looking at my clock because I want to be mindful of time. Jen, do we have until half past?
Yep.
Cool. So we built remotely. We wanted to have, again, a front row seat to all of the different services that are available in and across Azure. So not only is it built on Azure, we built it for Azure. So from a security perspective, that's really the first thing that I like to pick up and pick on, is that we're inheriting all of the intrinsic enterprise application security benefits from running in Azure. Secondly, and probably the coolest, is the use of Graph API. So some of you might know, there's a 6-lane superhighway, the Graph API, that's giving a tremendous amount of information by and across the different Microsoft services. So we're capturing a ton of that information and writing it to our console and remotely. Other things like geographic location and the other enterprise apps you're using, Microsoft licensing, both Azure Active Directory licensing or your actual Azure tenant licensing, are things that we have the unique ability to collect. And I'm going to show you the app here in a second. The cool thing is we wrote it in a series of microservices. From a security perspective, again, I kind of joked around. It's hard to pick up a newspaper without hearing some breach, either a company or an independent software vendor. We did not want to be in the front pages. So everything with us is segmented along the notion of microservices. So identity and admin management is its own microservice. Our security assessment module that I'm going to show you here is its own microservice. And then the management and monitoring segment is also its own microservice. So I'm going to show that to you here. Any questions so far? I know I'm going about 1,000,000 miles a minute, but I thought it would be a good place to jump in. All right, no questions so far. So with that, I'm going to log into the app. So what I'm logging into is our front end dashboard, which is doing a couple of different things as we're speaking. So first and foremost, that lightning bolt you saw with the 951 API calls being made across your Azure tenant just happened. So in the time it took me to speak, I don't know, 10 or 15 sentences, we got a ton of information from across Azure about your specific environment. So we start with the notion of the enterprise. Across your enterprise, what is the Microsoft Secure Score that you are encompassing or encouraging or encountering across your identity, your device, and your applications? Is this something that you've actually set a goal of, or is this something that you're aspiring to get to? And again, just to click over the moment of truth, we're getting all of the information that we're pulling in from your Microsoft 365 Defender instances. So next is the exposure score. So the ability to look at both the severity, the breadth, and probability of a breach in your environment. We're looking at things like your Microsoft Endpoint Manager compliance level, your Azure managed licenses from Azure Active Directory, as well as the Azure licenses for your actual tenants, the update rings for each and every one of the devices that are currently presenting themselves to Endpoint Manager. We see a list of all the applications that are presented. This was actually really cool. Without an agent, we had the ability to see every application that is presented by every machine that authenticates on the domain. The problem is those are usually tarballed up. They're not untangled. So we actually went ahead and untangled the fishing line, if you will. And so we can see the specific applications that each users are using. The notion we follow then is that all enterprises are made up of organizations, and so it's either the whole company or the Arizona Azure Virtual Desktop user group, or maybe the QA department. And again, because we're talking with Azure Active Directory and Active Directory trusts, we have the ability to go ahead and set up groups based on any existing OU that they might have in their organization. So the notion of enterprise, then organization, and then we go down to the notion of users. So I've got a bunch of different users and a bunch of different organizations. Ours happen to be named after ice cream. So I'm going to pick on Cherry Garcia. And so Cherry Garcia, again, is a user that has authenticated onto the network. He or she doesn't look like, let me take a look here. It looks like they're on two different machines. One looks like it's a laptop, non-compliant, one version of Windows. Second looks like a virtual machine with a second version of Windows. And I can see that only one of these machines is currently in one of my assigned update rings. So that second machine is probably non-compliant because of that reason. Next, I can scroll down and I start seeing some very interesting things about the Azure licensing. So what do I have available? How is it assigned? Are there different services that are either reliant or enabled because of it? And what is the assignment path? And again, you can go through and see all the different information kind of behind the scenes should you want to. Next, we go down to all of those endpoint manager applications that were discovered when they authenticated on the network. Again, this is all before we push out the agent I'm going to show you. We scroll down, and what I think the fun part is we start also seeing all of the Microsoft 365 Defender applications that were presented to the network, along with their NIST CVE vulnerabilities. And we took the time of saying, oh, let's go ahead and pick up and give the details behind the known vulnerability, and then let's actually go ahead and path out the remediation steps, because as you know, those can be pretty simple, but also have some pretty big impacts on your ability to change scores. So a ton of information lives in our database, and obviously it's important to be able to get data out. And so what we did is we wanted to have kind of a one-click simple button. We're calling this our online security assessment. So if you're an organization that has 100 or 1,000 or 20,000 users that have gone remote, it would be nice to be able to, in one click, pull up a report that kind of says, here's an executive summary of everything that we saw. Both the secure score, the exposure score, the weaknesses in maybe your enterprise applications and vulnerabilities, or specific lists of applications, with known challenges as well. And so each and every one of these reports can be customized. And the cool thing is that the way we output the data is actually in a format, hopefully y'all can see this, I know I'm going pretty quick, that is incredibly ingestible by Power BI. So all of the information that is available in remotely can also be reported on in Power BI. From a configuration standpoint, it takes 3 steps to set up remotely in your Azure tenant. We exist as an enterprise application, and so there's really 3 pieces of information that we need: the application ID, your tenant directory ID, and then of course the application secret. And we go ahead and make it pretty simple. If users have never set up an enterprise application before, this is about a 9-minute process, and usually it's just a matter of permissioning that you need to get right. And so we went ahead and just put a little instruction set there. So if it's your first time setting up an enterprise application, in about 4 steps, you're off and running. The other cool thing is, from an admin perspective, we understand that a lot of organizations have different roles, different tiers, different departments, different folks. So when we thought about being able to add a new admin into remotely, we said, well, should they have root access to everything? Should they be able to see and report on every one? Or should it be somewhat segmented? So we came up with the notion of either being an enterprise admin, seeing the whole enterprise, or an organizational admin. And if you're an organizational admin, as you'd expect, I could say, well, you can either see the whole company, or maybe you could just see the executives, or maybe just the test group. So that gets fun. So I know I have a few minutes left and I want to get to the cool stuff, but I want to get to the agent because that's really where the fun starts happening. So everything I showed you up until this point was done in an agentless fashion. We are simply reading those APIs from across your Azure tenant, bringing it all to a Cosmos database, and then putting it together in some neat graphical and actionable ways. But the reason we did that is we wanted to combine it with the telemetry from the edge. So the notion here is, well, let me give you also some roll-up information about those users on the edge, the CPU memory disk that they're on, the network and the Bluetooth or connection states that they're encountering. Tell me more about the device state. I mean, when was the last time it was rebooted? Does it have Microsoft, BitLocker enabled? Does it have Bluetooth on? Is there a live connection? How long has it been on since its last reboot? Where is it in the country? Power levels, active users, Windows firewall rules. These are all things that we're able to read because we're using PowerShell. So it's not just, the ability to just pull the WMI information. Things like the connected devices, the human interface devices that maybe have plugged in or out, left a driver. What I love is seeing the software inventory because I actually like picking on the uninstalled applications. What are users taking off the machines that we're giving them? We gave them local admin rights because they said they needed apps. I guess we never anticipated that they would be taking off our, anti-malware and virus software on their own. We also wanted to create a tab because we're reading all of the Windows log files as well. So from that endpoint, whether they're application service logs or whether they're system-based logs, we have the ability to pull that in into the platform as well. The measurements we're taking from the cloud and the measurements we're taking from the edge go into what we call our security risk index. This is our math. We wanted to actually come out with what is in essence a credit score that says based on the configuration, the consumption, the policies, the geolocation, the geopolitical threat level, give me a score of your remote users. And should they be remote? Quite frankly, should they actually be compelled to go to Azure Virtual Desktop? Is there something about their configuration, their app stack, or their performance that leads us to believe that they'd be a better candidate to connect through a thin client in a completely locked down environment? We believe yes. And we believe that all of the elements to help us as practitioners make those decisions exist right now. They're just not being measured in one place. And kind of like we talked about in the beginning, the pain and suffering to get that information in one place to help us make some really good decisions, up until this point was pretty difficult. I'm going to go ahead and say I think I have a minute or two left, so I'll take a breath and let you folks ask some questions because there's a ton of information that I want to share with you as well. Any questions so far, team? All right, I'll use my last 2 minutes. So what's coming? So obviously with great power comes great responsibility. And if we're going to be filling up some really fast databases with a ton of information from Endpoint Manager and Defender and Azure Active Directory and AVDI, I love the idea of maybe being able to pull some information from insights. We also have a PowerShell agent down on the edge. What are we going to do about it? Well, obviously, we intend to give all administrators the ability in the next release, or an upcoming release, I should say that correctly, to interact with those machines. So things like remote console, remote PowerShell, remote batch files, the ability to integrate with Teams or the other Office 365 apps, maybe even Zoom or ServiceNow. That's something we're going to be looking at. And then most importantly, we want to be able to truly use automation in a powerful way, meaning think about all the threshold or remediation tasks that we take manually every day, that if we had the ability to see holistically across our entire environment, we could actually start enforcing. If you're an executive and you walk into Starbucks, maybe you can use an external USB drive. And yet if you're another role within the organization, maybe he cannot. And so these are the kinds of things that we're going to start going down the path of the actual notion of adaptive policy management, seeing things and doing things based on what you see. And even though I know today was 27 minutes of T-Rex talking in one breath, we would love to invite anyone who saw this presentation, just visit remotely rmm.com/AVD. We put a little form up there. We'll send you some swag. I really appreciate the time here this afternoon, and we'd love to give you kind of a slower walk through and a deeper dive perhaps, and maybe even get you set up with what we call a POV, a proof of value. It takes about 30 seconds to 10 minutes to get hooked up to your Azure environment, and we'd love to show you what we're up to. So with that, Jen, I hand the microphone back to you, Ben and Thomas.
Thank you. This has been great. I think you answered all the questions I had.
All right. If there's more, I can always be reached all over the place. I'm not sure how the best way to get me, but probably shoot me a LinkedIn message.
Sure. Good content, and we hopefully could you post that link in the chat? Do you mind? So folks can have a way to get that demo and
Done. I'll do it
yes,
right now.
thank you. Thank you. It's fantastic.